Let me see. Let me go back over here. See where we're at. What's going on. And let's go to the website here so you guys know we were working with what? Antiderivatives. Is that true? Yes. So how do you guys like antiderivatives? Anybody like them? I think they're great. And this, what we're going to look at today is, I'm going to put up here for you guys, an application of antiderivatives called differential equations. So I'm going to put that in the chat. Okay. And let me go to your book really quick. Yeah, your book doesn't give a lot, of information about this. It just says, hey, let's go take a look here. I have this worksheet on my website known as Antiderivatives and Differential Equations here. Right? So what I'll write down here now as well on my notes is exactly that. So let's see what they're talking about. So let me go back here. I'm going to get this first question here for you guys. Really? Number one, they have here, they gave you a derivative equals the square root of x to the fifth power minus 4 over the fifth root of x. Okay, so here's what they're saying. Here's the first function they gave us, and now they're going to say to you, determine the function f. Okay? So you might say, what in the world did they give you? Well, they gave you, first of all, an equation. Would you guys agree with that? And it's an equation that involves what? A derivative. So from very, very simple first principles, an equation that involves a derivative, that's really called a differential equation. And when you take 261 beginning calculus, they introduce you to a differential equation, but there's whole courses in differential equations. So you guys can take a whole course in what's called differential equations. Anybody here, have you ever heard of that course, by the way? Yeah. You plan on taking it? I hope. It was one of my most favorite math courses when I was here as a student. It was one of my favorite courses, differential equations. Anybody here plan on taking it? It was one of my favorite. It's an amazing course.
What are the prerequisites for that?
I think it's Calculus 2.
I thought it's like after linear.
They might have changed it. So in some campuses, it's Calculus 2. Others, it's Calculus 3.
I know linear is Calc 2.
Linear is Calc 2. Yeah, and some campuses, it's Calculus 1. Because some of these campuses, they're free to locally change some of those things. And, I work as our curriculum chair in the district, so I'm already aware that, some do that to try to get students to take them earlier. I don't, you guys already know what I have to say. It's important you do it right. And that's my personal preference or philosophy about everything. Do it right. But not everybody does it right. Sometimes they do it for their own reasons, I should say. So yeah, so some campuses they'll have slightly different prereqs. Slightly different. But whatever. You guys know, is there a price you pay for cutting corners? There's always a drawback. There's a price you pay. And so sometimes people cut corners and there's a price they pay for it. And then there's another phrase I got here, really, that I use in my life that I think about. It's very philosophical. Sometimes people are willing to pay the price, but they're not counting the cost. That's pretty deep. I want you guys to think about that. What does it mean to pay the price but not count the cost? They're really willing to cut those corners and not consider what it really costs them at the end. Anyway, interesting. So you got a whole course in differential equations. It's an amazing course. Now you might say, what does that even mean? Well, what you guys have is a derivative of a function equals another function. And so what they give you in this book, is what happens if you have this situation. What's the solution? Well, the solution really is this. F, the function they want you to determine, is the antiderivative of g plus c in general. So this is really an antiderivative question. So I was looking in your book earlier and trying to find the differential equations section. There is a whole section in our book. I'm not sure if it's still there. It may still be there. I don't know. But they used to have a whole section. You don't cover it in the calculus course. You just cover this topic because it's an antiderivative topic. In other words, this is what you need to find. This is the g, I should say, in your definition. There's the g. So the solution for f is to find the antiderivative of g in general plus your c. That's what f is going to be. You need to find that solution, f. So it comes back to, can you get an antiderivative here, okay? So let me do a little bit of algebra for you guys here on this. If you guys remember, isn't this really going to be what? What is that function? Let me bring it all the way down here, okay? Let's bring this down. Here's your g function, okay? So little g is x to the what? 5/2 power minus 4 x to the what? Negative 1/5 power. Okay? So we need the antiderivative of that function. This is the g function in that definition. Okay, you guys with me on that? Because they're saying if you have a differential equation where you take where f prime, this is at f prime, equals g, they want you to find the f function. What is f? They gave you the derivative, f prime. What is f? So that's where this comes from. So it's your very first differential equation in your life. It's really get the antiderivative function called big G. And you guys know, how do you get the antiderivative of x to the 5/2 power?
Plus 1.
Yep. You're going to use, what do we call that again? Power rule. Good. And you have properties here. You're going to use the power rule again. And then at the end of the day, you're going to add that c there. So this is power rule. You guys okay with that? You use power rule here. Power rule over here. So it comes down to arithmetic. So 5/2 plus 1, isn't that going to be 2/2? Right? Right? Adding a whole number with a fraction, and this will be 5/5. So you're just going to use your, your arithmetic here. So the antiderivative will be x to the 7/2 over 7/2 minus 4 x to the what? 4/5 over 4/5 plus c. And then what's your final answer, ladies and gentlemen? What kind of arithmetic do you guys do here? Do you guys remember? What's your arithmetic here and here? Isn't that going to be 2/7 x to the 7/2 minus 4 times what? 5/4 x to the 4/5 plus c. And then do your arithmetic over here. Right? What's 7/2? Anybody remember? Simplify that rational. 7/2, isn't that 3.5? And then you cancel. So it's minus 5x to the what? 4/5 plus c. So go again. I did do that algebra video for you guys here because that's very often the most common thing that people ask, right, in a calculus course. You say, well, how did I simplify that? Well, that's x cubed what? Square root of x minus 5 fifth root of x to the 4th plus c, and then that's simplified. So there you go. So ladies and gentlemen, there it is. This is your first solution, and that g, by the way, is really the f function they're looking for. Okay? I know you say we called it big G, but that's going to be your f. That's the solution here. So what are they saying? F is really g of x plus c. Well, we'll just write it that way. And there's your solution. So it's just finding antiderivatives, what we've been doing the last few days. And then, like I said, in some ways, a big hurdle is out of the way. If you've worked on antiderivatives, a big hurdle is out of the way. Because we're really looking at an integral. You just need to learn the notation and what it means. And then that's that. And so, ladies and gentlemen, there you go. This is a general equation for a differential. 8x minus 3 secant squared x. Okay, here's the original function. Notice they gave you again a derivative, and they want you to find f. Okay, so all of these examples, they want you to determine what? F. Okay, so if you like, again, I'm going to use the colors. In the definition that I gave you, that's g, little g. F will be the antiderivative of g plus c. We'll use that notation, okay? There's your solution. You just have to know antiderivatives. Now, how do you guys find that first one? Do you guys remember? This is x to the what? First power here, right? So keep your constant and use the what? The power rule, minus 3, and then tell me what's the derivative or the antiderivative of secant squared? Isn't it just what? Tangent. So you're going to have to memorize that. Is that right? And then add your c. This will be your solution. So the rest is going to be just your arithmetic. So the original function will be 8 x squared over 2 minus 3 tangent plus c. The original function is going to be 4x squared minus 3 what? Tangent plus c. And there it is, ladies and gentlemen. What do you guys think? Number 2. Easy peasy lemon squeezy? I don't know. Let's look at number 3. So number 3 comes along. I'm looking at my worksheet here. They give you a derivative of f is 2x minus 3 what? Sine x. And then they now have f of 0 equals 5, okay? You're still trying to find that derivative. That solution is going to be if you let this again be that g function in the definition. Okay? Your solution is still going to be the antiderivative of g plus your constant c. You're looking for f, and that's how you get f. Okay, they gave you a differential what? Equation here. It's a derivative. They want f now. Okay, let's find the antiderivative of that g now using properties and power rule and whatever we have to memorize, right? Those trig antiderivatives. So, what's the power rule say? Add 1 divided by that 1 plus 1 by the power rule, right? Then I have minus 3. What's the antiderivative now of sine? Do you guys know what that is? What is it? Derivative of cosine is minus sine, so the antiderivative is minus what? Cosine, and then add your what? C here, okay? So the general solution will be 2x squared over 2 plus 3 cosine x plus a constant c. The 2's cancel. The function f becomes x squared plus 3 cosine x plus c. So you say, oh, okay, I guess I'm done, right? You're done. But then you notice, what did they give you? F of 0 equals what? 5. They applied a condition. This is known as a condition, by the way, to the function. They applied the condition that, you know what, when x is 0, the function is 5. Now, you might say, what does that even mean? Well, you're looking at this picture here. This is called the general solution, so you guys know. By using the condition, okay, you get what's called a particular solution. The particular solution happens when this x value here is what number? 0. So you're going to plug in 0 here, 0 here, 0 here. Okay, you're going to apply the condition now. This means x is 0, and when x is 0, the function is what number? Right? When x is 0, your function's 5. So you say, what does that mean? Well, let's see. F of 0, if I plug in 0 for x, my favorite condition value. So f of 0 numerically, isn't that 0 squared? Isn't that 0 plus 3 times 1 plus c? Because isn't cosine 0 positive 1? And that now means 5 equals what? 3 plus c, or c will be 5 minus 3. Your constant is 2. So when you apply the condition that they give you, ladies and gentlemen, that gives you the constant value c now. What is the value of c here? 2. Now you might say, what does that even mean? Well, this is what it means. This is your real conclusion. That the function now, since you have the constant, is going to be x squared, okay, plus 3 what? Cosine x plus that constant is 2 here. So you solve for the constant By using the condition. So instead of having a general antiderivative, you now have a what? Particular antiderivative. Because this is just a family of solutions. You now have a particular solution. And, that's kind of what they're looking for, a particular solution. So with this equation here, this function, yes, if you differentiate it, it is going to be, 2x minus 3 sine x. And then the value of x being 0 gives you 5. Yes, this is now your particular what? Solution. And so if they give you a condition, they're looking for a particular solution. Okay, you guys okay with that? Easy peasy lemon squeezy? What do you think? Isn't that applying your knowledge of antiderivatives? And that's, and that's kind of what we're going to essentially do from here on in. Apply your knowledge of what? Antiderivatives. So, number 4 here in that sheet is a sort of scary question like they gave you yesterday. And then they apply the condition here that when x is 1, when the input's 1, the output is 3. So they give you a condition. So they're looking for a particular function now. Okay? And again, this is a differential equation here. And then over here, you're going to have to use some what? Algebra. You might say, well, what is the algebra, right? Because remember, do you have a quotient rule property for antiderivatives? The answer is no. There's no quotient rule. There's no product rule. There's no quotient rule. There's sums and difference properties. That's a quotient. So that's why I say use algebra. What do I mean? What's the only algebra you can use? The only algebra you guys can use here is called beginning algebra. Is that right? Or maybe it's really intermediate because you have this. What is this? Do you guys remember? So it's not beginning algebra. In that 1/2, don't you use properties of exponents? Right, so it'll be x plus by intermediate algebra. 1/2 minus 2/2. Isn't that negative 1/2? All right, what do you guys think? Is that one okay? Good. Now, what is this portion going to be? This is the what? Isn't this the g function in the definition? So my solution, f of x, will be the antiderivative of g plus c. All right, you guys okay with that? Can you guys use the power rule here and some arithmetic? What are you going to be doing for Thanksgiving? Antiderivatives. Good answer.
Now you're gonna cook your turkey with calculus.
Yes. I already told you guys that story. I hate to say it. Isn't that sad? Isn't that a sad story? Your mom has to tell you to put your books away? Isn't that sad? Because she wants you to eat turkey, so you have to put your book away. All right. Oops. I have to do my arithmetic correct. I'm starting to think of my mother. X to the what? 1/2 divided by, and that's to be minus another 1/2. Is that right? Plus C? Let's make sure. I'm thinking of mom. Okay, does that one look good to you guys? What do you guys think? Does that look good? I think we're okay. Thinking of my my mother. I got to go visit her.
Does she make tamales?
Well, she passed away, so yeah. So I'll be visiting her in the cemetery. Huh? Oh no, don't worry about it. But she didn't make tamales, by the way. My grandmother did. My mom never really learned how to cook. My mother-in-law will make tamales. F of 1 equals 3. I'll be buying the ham. She'll be making the tamales. Huh?
Sounds like a plan.
Yes, it does. And probably the next day is even better. Because then you get to fry both the ham and the tamales. And you go, Mr. Judge, you fry tamales? Doesn't everybody? No? You guys don't fry those tamales?
Fried them? No, I haven't tried like that.
You never did that before? Oh, really? Like the next day, you know, because they're kind of dry after. If you don't eat them fresh, they're dry. Like the next morning, what you can do is you fry those tamales and you have it with your eggs. Try that out. I fry the ham even. Leftover ham. That the next day is even better. Anyway,
It's that marinade.
well, I get a honey baked ham. Sorry, I cheat. Honey baked ham. Is that cheating? I don't think so. I just have to heat it up. Oh, I told my wife yesterday, defrost the food. One year she didn't do it. I gotta remind her. I already texted her. Anyway, let's apply the condition. Put 1 for x. And what do you guys get? This will be now really f of 1, which will be 3, is 1/2 1 squared plus 2 times the square root of 1 plus c. So that is our 3 is what? 1/2 plus 2 plus c. You guys okay with that? So solve for c. That's what you're doing. That's what that condition gives you. Okay? So now you get 1 minus 1/2. What does that mean your c is going to be? Right? 2 over 2, 1/2. So the condition will always give you your constant, and that's what you're looking for. You're going to get the particular solution here. Okay? So here's your function now. F of x, 1/2 x squared, plus 2 square root of x, plus 1/2. That's the particular solution. I don't want that arrow. All right. You guys okay with that? What do you guys think? Easy peasy lemon squeezy? It's probably easier than making tamales. I think it is. Huh? I think
You gotta have patience.
it's very hard, and it's very. I'm going to say this. This is blasphemy, but it's true. Not every tamale is created equal.
One time I got a chicken bone. But that was in my job, so like,
Yeah, I know.
you know what I mean? It's like it was on the run.
I don't think I used to actually when I was president of our union once, and I used to bring Liliana's tamales for our meetings, and that was when they were good. and they're no longer good.
Oh no.
They're horrible. I don't know why people go there. I shake my head every time I drive by and I see a line. I'm like, are you kidding me? It's like the worst place. Horrible. You know, if you guys know, if you've ever been there, it's like really bad. But my mother-in-law, she does it right. I got to admit, people, and she does. She doesn't even complain either. If you guys know, some moms and grandmas complain about it. You know, not her. She doesn't complain. She does it. She does the hard work. She does it herself. No help. Like, wow. Anyway, this is called a second degree differential equation. You go, why is that a second degree? That's a second derivative. So what's going to happen when they give you the second derivative versions of this? They can give you a second derivative. They can give you a third derivative. You're going to have to just do the process twice. So what happens here is let's do this. Instead of f, you got f prime. And that'll be the g of x plus what? C here. So this is still your g. All right, so you go, okay, so undoing a second derivative means you're going to get a first derivative. So now, ladies and gentlemen, let's see what we end up with. What's the antiderivative of 1?
X.
It is x. You guys remember that? Because you say, I don't know, put x to the 0. You're going to get x. Minus 6. What's the antiderivative of x to the first power? 1 plus 1, 1 plus 1. Is that right? 48. The antiderivative of x squared. Isn't that going to be what? 2 plus 1? Plus a constant c. Let's do some arithmetic. Okay, let's see what this is. This is f prime. We have what? X minus now 3x squared plus 16x to the cube plus c. Okay, so double check. Okay, because we went from a second derivative now to a first derivative. And then you might say, but Mr. Judge, they gave me 2 conditions, right? I'm going to say you're going to have to use this one. Does anybody know why you got to use that condition?
First derivative.
Yeah, because you have a first derivative now. You don't use that. You don't do f of 0 as 1. You don't have an f function yet. So this is the condition you apply. So plug in the 0, right? Plug in that 0 there. And I really like 0. 0 is like my favorite number to work with because this now means we have, if we look at every detail, we have that what? F prime of 0 becomes what? C. But f prime of 0 is 2, so that means c is 2. So this number is what? 2. So that first derivative, f prime x, is x minus 3x squared plus 16x cubed plus 2. Okay, you guys okay with that? And then you say, well, how do I get f? After I got f prime, what do you guys think you have to do? you apply again the same principle, or I should say, take the antiderivative. This is your new g now, if you want to look at it that way. This is the new g. Weird. Okay, now to go from f prime to f. So here's the first power. Here we go. So ladies and gentlemen, here's what you're going to get now. X to the 1 plus 1 over what? 1 plus 1 minus 3 x to the what? 2 plus 1 over 2 plus 1. 16 x to the what? 3 plus 1 over 3 plus 1 plus 2x plus a c. Okay? And I know it's hard to see there. That's where all the mistakes happen. 1/2 x squared minus 3 x cubed over 3 plus 16 x to the 4th over 4 plus 2x plus your constant. So we get 1/2 x squared minus x cubed plus 4x to the 4th plus 2x plus c. And so, ladies and gentlemen, how do you actually get the particular solution? Well, guess what? You have this condition of f of 0 being 1 now. You get to apply that condition now. And the nice thing about this one is because you now have that what? 0 again. So if you ever get 0, that is an easy one to deal with. Right? Plug in x is 0. F of 0 really is going to be what? C. Is that true? Because all those values are going to be 0. If you square 0, you cube 0, fourth 0, that's zeros. And then you say, well, that means 1 equals c. Is that right? Because this is 1. So your function here at the end of the day, 1/2 what? X squared minus x cubed plus 4x to the 4th plus 2x plus the constant 1. Here it is, ladies and gentlemen. And there's your function. All right, you guys okay with that one? That one's number what? 5. What do you guys think? Is that the application of antiderivatives? So like I said, it's kind of home free in a way. You said, wow, antiderivatives. That's why you want to spend your time working on those. How about this? 2x cubed plus 3x what? Squared minus 4x plus 5. And they give us, I like f of 0. F of 0 is 2. And then they give us f of 1 equals, what is that? 0. So this is not a typo, by the way. All right. Okay. Say, well, how do we handle this? Well, you're going to take that second derivative. This is your g. So your solution is not going to be f. It'll be the first derivative. So 2x to the 3 plus 1 by the power rule, right? And then 3x to the what? 2 plus 1 over 2 plus 1 minus 4x of that 1 plus 1 over 1 plus 1 plus 5x plus a c. So this derivative will be 2x to the fourth over 4 plus 3x cubed over 3, 4x squared over 2, 5x plus a constant c. Just do your arithmetic now. F prime x is 1/2 x to the fourth plus x to the cube minus 2x squared plus 5x plus c. All right, you guys okay with that? So we're going to compare and contrast this example now with the last example. Right? You might say, what do you mean? Yeah. Yeah, Shannon. On Kamal? Yeah, Shannon. Fry Alberto, you gotta fry the old ones, Alberto, not the freshly made ones. You gotta wait till they dry out the next day. That's what you gotta do. And then make them nice and crunchy. You gotta don't use olive oil either, use corn oil. That's the recipe. Sorry. Anyway, you say, what about these conditions? I don't see an F prime. This is not like the last one, is it? It's not like the last one. So what do you do then if it's not like the last one? Well, get F, because these conditions are in terms of what? F. There's no F prime. So these are two conditions now. Believe it or not, you're gonna see what happens with the constants here, okay? So since it's not a typo, let's find F by taking antiderivatives. Now, how good are you guys at doing the antiderivatives? How good are you guys at the power rule? You know what happens? Here's what I mean. If you take x to the fourth, you add 1, isn't that 5? So I can put 5 over 5. What do you guys think? And then what about here? 4 over what? 4. 3 over 3, is that right? 2 over 2, and then plus cx plus what? I'm going to put another letter D. That's a constant, okay? I like using other capital letters for my constants. So notice the antiderivative over here of c becomes what? Cx, right? And then you have that extra constant. So you're going to have two constants for your function, but just do your arithmetic now with your fractions. What I mean is this is what you're going to get. One-tenth x to the fifth. 1/4 x to the fourth minus what? 2/3 x cubed plus 5/2 x squared plus cx plus d. I'm going to have to use two lines so that we don't make a mistake here, okay? Now, notice there's two constants here, right? C and D. So I want you guys to kind of notice that. Here's a constant, here's a constant. What were the two conditions, though? Now we're going to apply the conditions, but you apply them one at a time. So notice the zero there is nice. Okay, f of 0, wherever there's an x, you put a what there? You put a 0. Do you guys know what that means? Let's see how nice that turned out. That means this. F of 0, well, you got all these zeros here. It makes that variable 0. That means this is just going to be d. Is that true? But we know f of 0 is what? 2. So this means our d is what number? D is 2, yes. So at this point, you might say, can I change this D to 2? Yes. That's what D is. Okay, you guys see that? All right, that's applying the first condition. So after you do the first condition, you're going to have to do now the what? Second condition. What's the second condition say? When x is 1, replace x with 1. You're going to get 0. So let's see. F of 1 is going to give you what? You know what's nice about 1? 1 to the 5th is 1. 1 to the 4th is 1. 1 cubed is 1. 1 squared is 1. When x is 1, that's just 1. So here's what you get. 1/10 plus 1/4 minus 2/3 plus 5/2 plus c plus 2. And remember, this thing equals 0, right? F of 1 is actually 0. So you might say that means 1/10 plus 1/4 minus 2/3 plus 5/2 plus c plus 2 is 0. Gotta solve for c. Oh man, what a nightmare. Anybody know what the LCM of 10, 4, what's the LCM here? Is it 30? I don't think so. Anybody know what the LCM is? How do I add all these? Do we have a nice symbolic calculator? Can the TI do symbolic arithmetic? I don't know. Anybody know what I'm talking about? Can the TI do symbolic arithmetic? Might have to Google. Sometimes there's a function on this thing that has symbolic. Should I Google that? TI-84. Simplify a fraction on a TI. There's no fraction key on the TI-84 Plus per se, but fraction tools are built into the calculator. So it isn't a fraction. Come on, get to the point. Setting the mode. Do you prefer fractions or decimals? What would you rather work with, improper fraction or mixed number? Yada, yada, yada. Okay, what do you do? To change the form of a calculated answer, press mode. Use the arrow keys to scroll to the 11th line to answers. You got 3 choices. Okay, so I'm going to try something here. Okay, I haven't done this in my life for the first time. I'm going to add these fractions with the whole number. Now, can I do this arithmetic myself? Yes. It's not that bad. I'm just wondering if the TI can do it. So, 1 divided by 10 plus 1 divided by 4 minus 2 divided by 3 plus 5 divided by 2 plus 2. And so we go, okay, here's our answer. Now, it says go to mode, scroll down to what? 11, or answers. I can't even see. Scroll in. 3 options? I don't see 3 options. Answers. Huh? There's two options. It's on auto, fraction type. What does that say? Numerator over denominator. Oh, I don't know. Anyway, let's see if this changes anything. Didn't change it.
All got it.
Fraction to approx mode. Fraction, approximate, impossible. Fraction to approx mode. Yeah, let me see. I can't even see here. So we're going to go back again. Mode. And go back to auto. There should be a fraction to approx mode. How'd you get it? You said you got it?
Yeah, I think it's probably different for that one though.
Yeah. Weird. It's going to make me do arithmetic. Okay. All right, whatever. Okay, what's the LCM? 40, 60? All right, so it looks like it's going to be, what is this going to be? 150 plus 15, 165. Did you get 171 over 60 minus 40 over 60 plus C plus 2? Looks like it's 131 over 60 plus C plus 2 equals 0, and that means C will be negative 2 minus 131 over 60. Or let's do negative what? 120 over 60 minus 131 over 60? What'd you guys get for C? I think I get negative what? Is that negative 251 over 60? Anybody know? Because I'm not really awake. Negative 251 over 60. So your final answer for the function is going to be what we see here. So we say, okay, f of x. Okay. One-tenth x to the fifth power. Plus 1/4 x to the fourth power. Minus 2/3 x cubed. Plus 5/2 x squared. Do we just get C? I think so. That's C, I think, right? Minus 251 over 60x. And I believe that was plus 2. Is that right? Yes, plus 2. We got C. So, ladies and gentlemen, here you go. Here's your solution. So it had some arithmetic. All right. Okay, so I guess we did have to do some arithmetic. No big deal. Okay, and then, ladies and gentlemen, you might say, what happens if they do this? What if they give you a triple prime? And that's just simply equal to sine. But they give us some conditions here. F of 0 is 1. f prime of 0 equals 1, and then f double prime of 0 equals 1. So, oh. Okay. All right, so what do you think we're going to have to do now to solve a third derivative equal to what? That g. Right? That second derivative function, I need the antiderivative. It'll be g of x plus c. So you're going from the third to the second now. So do you guys happen to know what's the antiderivative of sine? It's negative cosine. Good. Plus c. Is that right? But what do you guys know? Don't you have a condition to apply? Do you guys see that initial condition here? Let's find c. F prime of c is 1, or f prime of 0 is 1. So plug in the 0 here. And that means f double prime of 0, is minus cosine of 0 plus c. What's cosine of 0? Ladies and gentlemen, cosine of 0, this portion here, what's that number? Isn't that 1? There's 1. So f double prime of 0 by the condition was 1. So that means 1 equals negative 1 times 1 plus c, or 1 equals negative 1 plus c. What does it mean about c? C will be 2. So this number here is really 2. So the second derivative function is minus cosine plus 2. Now, how do you guys think you're going to get the first derivative here? Right? Use the antiderivative. This becomes your new g. Okay, the new g. So f prime of x, keep that negative 1 constant and just find this. What's the antiderivative of g? I'm sorry, of cosine. Isn't that just sine? You guys see what I'm saying? I put that negative 1 constant there, and then the antiderivative of 2 would be what? It's going to be 2x, right? Because you got the constant there. So 2x plus your c. So ladies and gentlemen, we're almost there. Minus sine x plus 2x plus c. Okay. You can apply the condition of what? F prime 0 was 1 again. That's nice. Plug in a 0. 0, 0. F prime 0 becomes negative sine of what? 0 plus 2 times 0 plus c. What's sine 0? 0. So that means 1 will be negative 1 times 0 plus 2 times 0, which is 0 plus c. That just means c is what? 1. So this constant is what number? This constant is 1 now. We're almost there. So the first derivative function minus sine plus 2x plus the c being 1. Okay, so there it is. We're almost there. We got to go from the first derivative now to the function Or this is now your whole g function here. This is g. So your function here, f, will be, keep that negative 1 times here, and then you need the antiderivative of sine. What is that antiderivative? Do you guys know? Isn't that minus cosine? Yes. Antiderivative over here. Antiderivative over here. So now we're going to have what? Plus 2x squared over 2 plus x plus c. So we get cosine plus x squared plus x plus that c. Okay? So this is what we get by getting your antiderivative. Don't forget now we have to use the last condition here. F of 0 is 1. So you get to plug in that 0 here. F of 0 would be cosine of 0 plus 0 squared plus 0 plus c. Cosine of 0 is what? 1. So this means 1 equals 1 plus 0 plus c. That means c equals 0, ladies and gentlemen. So you could get a constant being 0. So at the end of the day, that last constant doesn't contribute to anything. Right over here, c is 0. So what does that mean about your function? That means you're done. The function was cosine x plus x squared plus x plus 0. That means you are what? Done. This is the particular solution, ladies and gentlemen, for all of these antiderivative questions that I have here. If I can scroll out, I guess I can't. On my website, okay? You guys okay with that? So you should be able to do your homework really well now, right? On antiderivatives and these differential equations. What do you guys think? Easy peasy? Is it doable or is it impossible? All right, well, it's impossible and doable. Okay. Well, it's easier than making tamales. All right, we'll see you guys later tomorrow. Have a great day. Stay safe.